Hi everyone, welcome to Shrike Studies. In this session, we are discussing the important problems on Power System Analysis 1. This is the first problem on the first module and the question is draw the reactance diagram of the system as shown in the figure. They have given a one-line diagram and the ratings of the components are as follows. They have give the data of the components, that is generator, transformer 1 and transformer 2 and also the motor. Okay, so first whatever the data is given in the question, we need to note down. So generator value they have given, see here 15 MVA and then 6.6 kVA and they have given X value as 12%. It is in percentage. We need to calculate in the per unit, means we need to do by 12 divided by 100, that is 0.12 per unit. Okay, after that this is a transformer 1. See, transformer 1 is called as step up transformer. Why? Because the number of winding in the primary section is less as compared to the secondary section. That's why we say it as transformer 1 has a step up transformer. 20 MVA is there and the rating is they have given as 6.6 kV and 66 kV. I am rating first as 6.6 kV then 66. Why? Because this is a step up transformer and per unit is 0.08 and this is a transformer 2 T2. First I will write the rating as 66 kV then 6.6 because this is a step down transformer. The number of winding in the primary section is more as compared to the secondary section. And then 20 MVA and per unit value is 0.08 and motor 1 and motor 2 5 MVA 6.6 kV and the per unit value is 0.2. See, there are 5 steps to calculate this. Okay, first step is before going to the step, one thing we need to remember, if in the question if they didn't mention the base value to which to take, we need to take the generator value as a base value. This is a very important point, we need to note down it. They didn't mention what value we need to take as a base value. That's why we are taking the generator value. Okay, so first step one is we need to choose a base power, that is MVA B new and KVA B new for the entire system. Okay, MVA B new, we are taking generator as a base, right? So that is 15 MVA. I am writing the generator base value is 15 MVA and KV B value for the generator is 6.6 has already given. This is 6.6. Okay, then step 2. In step 2 we need to calculate the base voltage. And one thing we need to remember here is generator and the motor and the load always lies in the LT section and only the transmission line lies in the HT section. In this question there is no load, so leave it the load and calculate for generator, motor. Okay, we need to calculate the base voltage for transformer, generator and transmission line, generator and the motor. First we are calculating the base voltage for the transmission line. As we already know that transmission line lies in which section? HT section. So what is the formula for the HT section? This is a formula, that is KVB new on HT section. This should become LT section. LT section into HT voltage rating divided by LT voltage rating. KVB new on HT section. What is the HT section? LT section, that is 6.6 kV. This we need to take as reference value 6.6. Then HT voltage rating divided by LT voltage rating is there. So first is HT. We need to take the higher value, that is 66 first and then we need to take 6.6. 6.6 will cancel each other and 66 kV is a final answer. We have calculated the KVB new for the transmission line which lies in the high HT section. Next, we need to calculate for the motors, right? M1 and M2. As we already know that M1 and M2 lies in which section? LT section. Then what is the LT section formula? LT section formula and HT section formula are vice versa. Okay, if you remember HT section, you can write LT section formula. Okay, likewise. So the formula for the LT section is KVB new on HT section into LT voltage rating divided by HT voltage rating. KVB new on HT section is just now we have calculated. This is a HT section, right? This is a KVB new for the HT section, that is 66 kV is there. First we need to write 66, then LT voltage rating. First we need to write lower value, that is 6.6. Then we need to write higher value, that is 66. 66 will cancel each other and remaining answer is 6.6 kVA. Till now we have calculated the base voltage for the transmission line as well as for the motor 1 and motor 2. Since the value, the given data for the motor 1 and motor 2 is same, and the value will, base voltage will also remain same for both motor 1 and motor 2. In step 3, we need to calculate the per unit reactance for the transmission line. See, for the transmission line, they have given as a J60 ohm. It is given in the ohm value, right? We need to convert it into per unit value. We have the formula for that, that is xp nu is equal to x ohm into MEA B nu divided by kV B square nu on transmission line. So x ohm is already they have given, that is J60 into MEA B nu. We have calculated is 50 again, 15 divided by kV B square nu on transmission line. See, for the transmission line, it is a 66 kV is there. We have calculated in step 2. Write the value 66 whole square. By calculating this, we get the answer as J 0.47 per unit. Okay. Then in the step 4, we need to calculate the per unit reactance for all the components. Okay. First, we are calculating for per unit reactance of a generator. We have the formula again, XPU volt divided into MEAB nu by volt, KVB square volt by nu. See, XPU volt is there, no? For the generator, that value is 0.12. And MEA nu, this is new value and this is a old value, 15 by 15, 15 by 15. And KVB square volt, again it is same, 6.6, and here also it is 6.6. That is 6.6 whole square. By calculating this, we get the answer as J 0.12 per unit. Now again for per unit reactance for the motor 1 and motor 2. Okay, XPU volt, that is MEA nu and by volt into kV square volt divided by nu. For the motor, it is having 0.2 per unit. Write the 0.2 per unit value again here. And MEAB nu is 15 and volt is, this is 15. Okay, this is 15 by 15. And KVB square volt is, what is it? 6.6 is there. And KVB on, again, new value is 6.6. Okay, this is 6.6 whole square. We get 0.2 per unit for both motor 1 and motor 2. Now per unit reactance for the transformer 1 and transformer 2. That is XP nu for transformer 1, we have the formula, and for KVB square volt and nu, here little change is there. See here, it is having the transformer 1 is having the rating 6.6, right? It is connected to generator, that is 6.6. It is having the 6.6. 6.6 whole square 1. If you take the 66 kV as example, as reference, it is connected to the transformer 2, right? It is having a 66 kV. 66 by 66 whole square 1. So directly I have written here 1. By that you will get the answer as, this is J 0.06 per unit. Now for similarly we are calculating the per unit reactance for the transformer 2. PU volt is 0.08. Again the MEA new value is 15 and volt is 20. And again here KVB square nu, if you take for the transformer 2, see, it is having 66 by 6.6. If you take the 66, it is connected to 66 kV. 66 by 66 square. If you take the 6.6 of the secondary winding, it is connected to motor and it is having 6.6. 6.66 whole square, again it is 1. Whatever you take, you will get the same answer. By calculating this, we will get the J 0.06 per unit. Okay. In step 5, we need to draw the per unit reactance diagram. Okay, one generator is there, no? We need to draw one reactance along with the source voltage. And for the transformer 1, we need to draw the reactance. Transmission line, again one reactance. For the transformer 2, again one reactance. And two motors are connected in parallel, right? So, this is one reactance along with the source voltage, one reactance with along with the source voltage. This is called XM1, this is called as XM2. Okay, and whatever the per unit values we have got now, we need to write for transformer 1 and transformer 2 same, that is 0.06 per unit, 0.06 per unit. Transmission line we got 0.47 per unit, and for generator we got 0.12, and for motor we got 0.2 per unit. Okay, thank you. If you like my video, please like, share and subscribe my channel. Thank you.